And then our next one here, oh, that left-hand side looks like it just wants to have some simplifying done. And the right-hand side, well, we know that tan x is sine x over cos x. So we're kind of expecting the left-hand side to turn into sine x over cos x. Well, sine x over, well, denominator. If we wanted to simplify this, we'd need to factorize, hoping that something would cancel. First thing we do when we factorize. Yep, indeed, a common factor. So that's cos squared x plus sine squared x. Well, cos squared x plus sine squared x, we can simplify that. That's just 1. And, oh, well, that is indeed just that. Sine x over cos x, we've done all the hard work. But we could say equals tan x equals right-hand side. And, of course, we need to have a smiley face. Okay, well, that one was so quick. We'll do the next one in the same video. Okay, this one. Ooh, left-hand side and right-hand side both look quite juicy to work with. So, as I said, I kind of just draw my line down here in case I want to work with both sides. Now, the left-hand side, 1 plus 2 sine x cos x. And the denominator, well, the denominator, just, it's a difference of 2 squares. So it feels like we could probably factorize that, cos x times cos x, and then go plus sine x minus sine x. And by doing that, what we can see is that, well, cos x minus sine x is over here. So it feels like hopefully at some stage we can cancel that and be left with just cos x plus sine x on the numerator. Okay, maybe you get that sense, maybe not, but the idea is that denominator is already there. So it feels like we're on the right track already. Now, the numerator, 1 plus 2 sine x cos x. Nothing we can immediately do there. There wasn't a nice like sine squared x plus cos squared x. There's no tan x we can change to sine x over cos x. But wait, normally we go sine squared x plus cos squared x equals 1. Why don't we change this one to sine squared x plus cos squared x? And you might wonder, quite rightly, how would you do that? Okay, we'll see right now. Sine x, cos x. We've just created a nice trinomial that we could factorize. So just looking at the numerator, I'm going to rewrite the denominator so it's out of our way. Cos x plus sine x, cos x minus sine x. Now, as an aside, what happens if we're trying to factorize, say, x squared plus 2x plus 1? Easy game, right? You would just say, well, bracket, 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 x plus 1 plus 1. Something like that. Okay, what happens if instead of that, we had something like x squared plus 2xy plus y squared? Well, again, you would probably say, well, I can factorize that easily. X times x is x squared, and y times y is y squared, plus would give us the 2xy in the middle. But now in this case, they've got sine squared x's and cos squared x's. So I'm going to rewrite the numerator in a different order, and I'm going to write sine x plus 2 sine x cos x plus cos squared x. So that it looks a little bit like this thing on the right-hand side here. So not the right-hand side of the original equation. So that we can factorize. So our denominator stays the same. Nothing too exciting we can do with it. Sine x, cos x, minus sine x. Okay, but our numerator we can factorize because it's a trinomial. Now, sine squared x, sine squared x could be sine x times sine x. Cos squared x could be cos x times cos x. And if we went plus plus, well, our middle term is going to work because we're going to have sine x cos x plus sine x cos x is indeed 2 sine x cos x. Along the same lines that we had factorized this trinomial. It's just that instead of x and y, we've got sine x and cos x. Yeah, well, that was interesting because what that's allowed us to do is to have one term of one term. And now we can look for things to cancel. Goodbye to you, goodbye to you. And what we're left with is just sine x plus cos x over cos x minus sine x. And hopefully that looks like what we're given. Cos x plus sin x, well, it's the same thing. Cos x minus sin x, so we can happily say equals the right-hand side. Happy days. Of course, it's annoying when you get to the end and you go, but it doesn't look like the right-hand side. But in this case, it did, so hence the smiley face. Okay, well, that's it for now. And in fact, that's it. So enjoy worksheet 4. I think the worksheet 4 was a peanut, so enjoy it. And I think we should end with making it maths.